Okay, now that we have the calibration curve, how do we apply this to our green crystals? Okay, so we have some massive green crystals that we then put into that, dissolved into that 100 mil volumetric flask. We then took a 2 mil aliquot out of that, and then that was placed into a 50 mil volumetric flask. Okay. And so the question is, we're going to need this number a little bit later. You'll see why. How many grams of this green crystal made it into this 50 mil volume? That is a pretty easy calculation, right? Since we have this mass, and that mass is dissolved into 100 mils, and of that 100 mils, we're only going to take 2. So this is the number of grams of green crystal in the 50 mil secondary solution. Okay. So what else are we going to know? We're going to want to know our final volume from the dilutions we made, right? And just like before, those final volumes are going to be no different. They are simply going to be the amount of the iron BIPI that you made plus the balance of water to make the dilutions, right? They should be roughly 7.5, but you know, your mileage may vary. So you took each one of these dilutions and you got a transmittance, which is great. So we can take that transmittance to absorbance, right? Simply the minus log of the T, remember not the percent T, but the T, so we have to divide by 100, and ta-da, we get the transmittance. Great. So now we can take that transmittance and change it into molarity from our previous equation. Well, how do we do that, right? Well, let's go back to our calibration. Here's our wonderful curve. Let's copy that curve, Control C, come back over here, Control V, just paste it in. Yay, we can see our nice calibration curve now. Make it a little smaller, fit it over here. Looking good. We're also going to want to know our slope and intercept well. Remember, we calculated them. So we're just going to say this cell equals, and I'm going to come over here and click on the slope and hit enter. You'll notice it put in the dollar signs again for no reason. Anyway, so there's our slope. I'll drag to the right and down. It shows the values from previously. So remember, we're just going to take these absorbances, which are the Y value, and find the X value for the corresponding absorbance. And it's simply Y equals mx plus b, where this is the Y. So our absorption is going to be our Y, and of course then we have to minus our B. So this will equal our Y value minus the B value. I'll hit F4 because we don't want to change. And then to get the X, we'll then have to just multiply by the M value. And this is our molarity of iron BIPI in our solution. Okay, so that's going to be good. The next step would be to figure out, well, the number of moles. How many moles of iron BIPI are there in that container? So our moles are simply going to be our molarity, right, multiplied by our final volume, right? Of course, that volume has to once again be in liters, so we'll divide it by 1,000. And now we have our iron BIPI or iron molarity for each one of those solutions. So if we know how many moles of iron BIPI in there, which is 1 to 1 for moles of iron, we can now figure out how many grams of iron that is. And that's pretty simple. This is simply the moles times the molecular weight of iron. And so this tells us the moles of iron in each one of those solutions. Now we also calculated the number of grams of green crystal in each one of these solutions. So we're also going to want to know the grams of crystal of that green crystal that made it into each one of those dilutions. And that's not really hard calculation either, right? We have this 50 ml solution of green crystals, which I'll lock with an F4. And remember, that is, we have this many grams in 50, right? So that's 50 mils, right? We'll lock that. And then each one of these is simply multiplied by the volume of that solution we put in, which is this. And so now we're able to see the number of grams of crystal in each one of these solutions. And what's nice about this is now we can get the percent mass of iron, right? Since there's this much iron in there and there's this much crystal, this is simply the number of grams of iron divided by the total mass of the crystal. And multiply it by 100 to get a percent. That looks a little prettier. And you can see we roughly get 17 mass percent of iron. Okay, that's not too bad. But let's take a look at our data and we'll plot it on this calibration curve. Let's take the calibration curve, select data. We're going to add a data series. Remember, our X value is our molarity. Our Y value is our absorbance. And okay. Uh-oh. We have a red point here, and this red point is outside of our calibration curve. What does that mean? Well, in real life, would you accept that? Heck yeah, close enough. In our class, we are not accepting anything outside of those bounds. We are going to exclude it. So when we calculate our percent mass of iron, we will now exclude that point from the data set. And that is the least concentrated point. So we're not going to take the top one, right? Because this is outside the range. So our standard deviation won't include the top one. And our percent RSD is not too bad. So here you can see that we have roughly 17% by mass of iron in this green crystal.